Today we're talking about solving equations with the e that included in the equation. And this whole assignment basically has an e or natural log in the equation except for one problem. So what I thought I would do is I would work the problems for you in a video. Yes, this is going to be a long video, but if you just fast forward through it and find the numbers that you want to review, I would suggest actually working the problem first. See if you can work the problem, and if you're having a hard time, then go back and review how I've worked the problem. So let's start with number 1. We have e to the negative x equals 5, and I'm always going to look at converting to a log or converting to an exponential. In this case, I went from an exponential to a log. And when I did that, I got log e of 5, which I can put in the calculator. So if I just put the ln button and 5 in the calculator, I'll get 1.609. So I'm going to replace that log e of 5 with 1.609, and then I'm going to divide by -1, and your answer should be 1.609. Excuse me, negative. Just make sure that you're converting. I always think about converting it. There are actually other ways to solve these equations, and right now I'm using this method, and notice that I'm going back to one that we've talked about before. But in this case, instead of 2 to the third, I'm actually thinking it's 2 to the x, and the whole purpose is to get the x out of the exponent. Okay, so we have number 2 is 4e to the negative 2x equals 17. I'm going to divide by 4. That'll give me e to the negative 2x equals 4.25. We're going to get a lot of decimals in this assignment, so don't worry about that. So we have a log base e of 4.25 because I'm converting it from an exponential to a log. That'll give me equals negative 2x. And if I put log e, which is the natural log button, in the calculator, I will get 1.447. Okay, so I replace that and I divide that by a -2. My answer is going to be 0.723. Now, in some cases, these decimals are actually turning out really nicely, but in some cases, they're going to be non-terminating, repeating decimals, and so we're going to look at how to put that in the calculator in just a minute here. So our next problem is -3e to the 2x plus 16 equals 5. I'm going to start moving things over because there's no way to convert this yet. I'm going to subtract the 16, which gives me -11. And then I'm going to divide by -3. That will give me all the pieces that I need to convert it to a log. But 11 thirds is actually a repeating decimal. So I've got log e of 11 thirds equals 2x. And if I put the natural log button in there, I'm going to get of 11 thirds. You see how I put it in there? Because I don't want to use that repeating decimal. I want to get as close to exact as I can. Okay, so after I get 1.299, I divide it by 2, and your answer should be x equal 0.650. Okay, here is number 4. All right, so now we're into some different ones. I have the natural log of 4x minus 7 equals the natural log of x plus 7. Okay, remember that, just an easy example, a a log or a natural log of x equals a natural log of 2, naturally, then x would equal 2, without worrying about what the natural log of 2 would be. So I can basically take out 4x minus 7 and x plus 11 and set them equal to each other to find out what x is. If I subtract x over on the other side, I get 3x equals 18 because I've added the 7 as well. So x equals 6. And that's my answer for that one. I think we're going to do that again. This is number 5, natural log of x plus 19, and the natural log of 7x minus 8. Again, I can go ahead and just take out x plus 19 and 7x minus 8. If I subtract x on the other side, I get 6x. And if I add 8 on the other side, I get 27. So x is going to equal 27 over 6. In this case, the answer is 9/2. If you made that a decimal, it'd be okay, but that's not going to be the answer in the school web quiz today. All right, here we go. Number 6. 5 times the natural log of x equals 35. Please remember that you want to move everything over that's not part of the log. So if I divide 5 over, I get natural log of x equals 7. Notice that I am actually changing the ln to a log e. It makes it easier for students to be able to see that e and do the conversion from a log to an exponential. In this case, the answer is e to the 7th, or 1096.633. Whichever one you used is perfectly fine. Okay, number 7. We have 4 times the natural log of negative x plus 3 equals 21. Remember to move the stuff over that's not part of the log. So we're going to move the 3 first because that 4, we want to do that last. So there's 18, and if we divide by 4, we get natural log of negative x equals 4.5. I'm going to go ahead and write out the ln, make it log e of negative x equals 4.5. And now you have e to the 4.5 equals negative x. I have just converted from my log to my exponential. My answer is going to be 90.017. So my negative, okay, now let's just remember this. Because the answer is negative 90.017, when I put the answer in for x, then it becomes positive. As long as this whole thing becomes positive, then the log will work. Because remember, the log base e or a log base of anything is not going to make a negative number. So in this case, what's going to happen is the negative 90 is going to make it positive. Okay? Now, the log, let's repeat this. The log of a positive number with a base of a positive number is never going to make a negative number. If the answer is negative, and when I put it in here, if it becomes positive, then it's okay. So this answer is actually okay. You know, watch out for that on your problems when they ask to look for extraneous solutions. All right, here's number 8. We have ln, or natural log of x plus 3, plus the natural log of x equals 1. Okay, we're going to condense it, so it's the natural log of, I'm kind of switching these around, I like it better this way, x times x plus 3 equals 1. So now we have the natural log, which I'm going to go ahead and write the log e, of x squared plus 3x equals 1. And now I'm going to convert to an exponential. which is e to the 1 equals x squared plus 3x, which e to the 1 is just e, so I'm going to subtract e on the other side. And now what do I have? A quadratic, which means that I'm not going to be able to factor this. So for number 8, I'm going to have to use the quadratic formula. So I have x equals -3 plus or minus the square root of 3 squared minus 4ac, which is 4, 1, and negative e. Okay, we're going to go ahead and use the decimals because remember we're not going to simplify these radicals in this chapter. So we're going to go -3 plus or minus, and I'm going to go figure out what my radical is going to be. Okay, notice I did 9 plus 4 times e, because a negative times a negative is going to make a positive. So this is going to be 9 plus whatever 4 times e is. I'm going to use the e in the calculator, which is the second button and the divide button. So I got 4.458. Now, watch this. I can actually tell that a negative and a negative divided by positive is just going to be a negative number. And a negative number that goes up back into that log is still going to cause a negative number. So I know the log's not going to work with that one. Okay? Part of the original problem was a natural log of x. And I know there is nothing that I can take e to the exponent that's going to make a negative number. Okay? So therefore, I'm only going to use this positive one, which is -3 plus the 4.458, and then divide by 2, which I get 0.729, which does work in the natural log. All right, here we go. Number 9. These are the two word problems that are in the example, or excuse me, in the assignment. Okay? So the word problem is talking about the amount of radium in a container. It wants to know how many years will 5 be left in the container. So I replaced the r with the 5, and I divided by 100 because I knew that's an extra number. I don't want that in there. Okay, I want it to look like an exponential with all the proper pieces so that I can convert this to a log, which means that log e of 0.05 equals, I'm going to take that whole exponent, this whole thing right here, goes down here. And I think this is the type of problem that people actually have a hard time with on the quizzes and the test. So, okay, so I put in log e of 0.05 in the calculator, which is just the ln button, 0.05, and then I divided by a negative 0.0043. And my answer ends up being 6,966.82, which if I round that to the years, because that's what the word problem is asking for, I get 6,967. Okay, number 10. Now, this is the one that doesn't have an e in it, but it's important to talk about compound interest and what happens when you put money into an account that is gaining interest, and how long does it take to build a certain amount of money. So at this point, they're asking for $1,000. They want to know how long it's going to take to make $1,000. This interest rate is really low. This is 6% interest, okay? And the principal, which is the amount that we put into the account at the very beginning, is just $100. And so we go ahead and plug in the 0.06 for the rate. Notice that this 100 is extra. I'm going to move it over here, so that's going to give me a 10. And I'm going to go ahead and add this number together, 1 plus 0.06. And then I have a t because t times the 1. Okay, before we start the log, let's just do one thing. The annual, the compound means how many times is it calculated throughout the year, okay? So if I'm going to only calculate this one time throughout the year, then I'm going to look at just once in the year, okay? At the same time, when it does quarterly, then I'm going to go 4, and at the same time, if it's compounded daily, then I'm going to use 365. So this time for this piece, this is, I think, letter A, the part of the problem, I'm going to do n equals 1. Okay, so I just wanted you to know where that n was coming from. All right, so we're going to do the log. Log base of 1.06 of 10 will equal t. Okay, so let's do log 1.06. Make sure you get 1.06 in there. Okay. And then you got to put in the calculator, use our trick on how we put that in the calculator, because we can't use the natural log button this time. You should have gotten 39.52. I think the book says 40, but we're going to actually use the decimal this time. Okay, this problem again, we have to look at compounding quarterly. Quarterly means 4 times a year. And so we're going to put our numbers back in, except for this time the n is going to be a 4. So when we get down to it, we're going to be dividing by 4. We're going to go ahead and divide that 100 over so we get the 10 again. And if we do 0.06 divided by 4, we get 0.015, which means I've got my number for the inside right here. I'm going to convert it to a log. And we've got to divide by 4 in the end. So we're going to do this first. We're going to do the log first. Okay. Okay, so watch. We've got the log first. So you're going to go log 10 divided by log of 1.015. That'll give you the 154.65. And then you have the divide by 4 at the very end. That will give us the time of 38.66 years. I think the book might have said 38.75, but that'll be okay. All right, so let's see here. We've got the same equation. Okay, you have 0.06 divided by 365. This is daily for our compound interest. We're going to put the 365 here, which means I went ahead and divided by 100, added these together, which gave me 1.0016, and I'm going to convert it to a log. We're going to divide that, in the end, we will divide that by 365. So let's do the log first, which is going to give us 14,008.544 divided by 365. And that will be 38.38. Do you notice how it takes a short amount of time to build that money if you compound daily? Okay? So, look over these problems. Let me know if you have any questions, and have a great day.